All right, in this video, we're going to look at the law of sines. And the law of sines looks just like this. It's ratios, and we know that we can take the side length over the sine of its corresponding angle, side length over corresponding angle, side length over corresponding angle. So what do I mean by that? Just like we did with law of cosines, if we have any triangle, if this is angle A, this is side A. If this is angle B, this is side B. If this is angle C, this is side C. So if we can set up those ratios, we can then use any combination of the ratios, like this one and this one, to find missing sides or missing angles. So law of sines works really well if you're given two angles and one side. But if you only give two sides and one angle, then there's three possible outcomes that occur. So this is a little more entailed than the law of cosines. So there's three ways that this can work out. Either you have one triangle, two triangles, or there's zero triangles. So we're going to walk you through this. And it's a little long, so just hang on for the ride. So the single solution case is when they give you two angles and one side. Now you know it's going to be a single solution because we know all three angles have to add up to 180, right? So if they add up to 180, then I only know that this one example is giving me A or C and B. I need to find angle A. Well, there's only one angle that will work because I know that 180 minus 102.3 minus 28.7, there's only one solution to that, right? And that one does come out to be 49 degrees. So angle A has to be 49 degrees. There's nothing else it can be. Therefore, it's a single solution. Now, what else is missing from my triangle? I need to find little side A, and it looks like I need to find little side C. All right, so I know I'm done when I've found all three parts here. So I can use then the law of sine to help me find the missing sides. So let's see. Let's start with side A. Little a over the sine of what did I just find angle A to be? 49 equals, I need little c, but I don't know it. So I have to pick something I do know. So I know little b is 27.4 over the sine of angle B, which was 28.7. So I'm going to do some algebra. I'm going to solve this. If I cross multiply, I'll have 27.4 times the sine of 49. And then to solve completely, I'm going to have to divide all of this by the sine of 28.7. All right, using my calculator, I'm going to plug all this in. And I'm going to find that comes out to be 43.06 degrees. All right, that's little, or not, it's not degrees, is it? It's a side length, so I don't need degrees. So little a is then 43.06, whatever units it is. In this case, looks like feet. Okay, now we're going to find little c. So we're going to go the same way. Little c over the sine of big C equals, you can use anything you want. I usually use the given amounts. So 27.4 over the sine of 28.7. Again, I'm going to cross multiply. Then I need to divide both sides by the sine of 28.7. And when I get that, it comes out to 55.75. All right, and that would be feet, so 55.75 feet. Now that I found the missing parts of my triangle, I know I'm finished. All right, so a single solution is not so bad. It's a little tedious because you've got to find missing sides and whatnot. But let's kind of dive into the ambiguous case. Two sides and an opposite angle. So I'm going to walk you through it. Two sides and an angle. So this means I need to find angle A angle C, and looks like little c, right, to be finished here. So we have to start with what we're given. The only thing we can do at this juncture with this information is to find angle A. So let's do that first. So we're going to do little b over the sine of angle B, which is 42, equals little a over the sine of big A. Right? Cross multiply, and let's see what we get. 12 times the sine of 42 equals 22 times the sine of A. Well, I need to solve for the sine of A, so I'm going to divide by 22. Now, when I do that, I have the sine of A equals, what is this going to come out to be? This comes out to be 0.36498803, whatever. Now, to find A, then I have to do the inverse. A would then be the inverse sine of this value. Just keep that all tracking in your calculator. So this comes out to be an angle of 21.406 degrees. Okay, great. So angle A is 21.460 degrees. Now the question is this just A1 of two different angle A's, or is there only one triangle solution? So what you have to do is think about sine for a moment. In our unit, when we think about a unit circle, angle of 21 is right here, and it has an xy, a sine value, right? The y is positive, we know that. But we also know that there's an angle over here that has the same y value. The x is negative, but the y is positive, right? So because that these y values are the same, that means the sine would be the same at both angles. Well, what are the two angles? Well, the two angles are this angle 21 that we just found, and then this angle over here. So we could find that angle by taking 180 and subtracting the 21 that we have. So if we do that, we're going to have 180 minus 21.406, and we get 158 and some change, 0.59. Well, okay, so how do I know if that means there's another triangle? Well, you take the given angle, which was 42, and add it. If I add it and it's greater than 180, which it is, it's going to be 190, almost 200, then that means there's only one solution. There's only one triangle solution to this problem. So I don't have to worry about a second triangle. So we're going to finish this question just as we would the first one. So I'm going to find big C now. I know it's 180 minus the 42 given, minus the 21.406 that we've already found, and what's left over is my big angle C. And that means it would be 116.594. Okay. Now, to find little c, I'm going to do little c over the sine of 116.594 equals, what do we know? We were given the 22 and sine of 42. Running out of space, but when I do my cross multiplication and solve, I find that little c is 29.400, and our unit is inches. So 29.400 inches. So now I've solved this. There's only one triangle solution, and we're done with it. Let's try another one. All right, we're going to start by just looking and see what do we need to solve here. We need to find big A, big B, and it looks like little a. Okay, we only have one angle, so it's ambiguous. We're going to have to do some investigative work here. But let's start with what we know. We know that little c is 15, and over the sine of big C, I can find the sine of big B. Okay, so if I do my algebra, cross multiply, I know the sine of big B would then be equal to 25 times the sine of 85 divided by 15. So my calculator tells me that the sine of B is then 1.66, on and on and on. Now, if I do inverse sine on this, my calculator is going to come back with error. Oh, goodness. What does that mean? Well, think about our unit circle. What is the highest value a sine value can be? Well, it was 0, 1, wasn't it? Can't be greater than 1. So if I'm ending up with the sine of an angle that's greater than 1, then this triangle does not exist. So you just stop there and you says does not exist. All right? So let's try example 3. Again, only one angle is given. So I need to find big B, big C, and it looks like little c. So we're going to start with what we're given. Little a over the sine of big A, which was 20.5, equals little b, 31 over the sine of big B. Okay, if I do my cross multiplication and algebra stuff, I'm going to end up with 31 times the sine of 20.5, all divided by 12. So I'm going to get a decimal answer here, right? This is going to be a decimal. And so when I do inverse sine of that value, I find out that big B is 64.783. Okay, so 64.783. So I need to decide, is there a second triangle here? Is there a second big B? So same steps as before. I'm going to take 180. I'm going to subtract that 64.783 and see what I get. When I subtract, I get 115.21. Then I ask myself, okay, can I add the given angle? They gave me 20.5. If I do that, I'm still under 180, aren't I? So that tells me that there is a second triangle. So I'm going to label this as big B1, big C1, little c1. And then I know that there's a big B2, big C2, and a little c2. So this is going to take a minute to solve, but we can get there. Now, what we've already found big B2. Here's the thing. When you do this subtraction step right here, and you get this number, if it works with the given value, then that is big B2. All right? So we know that this one is 115.21 degrees. I'm sorry, I should put degrees on there. Okay, that being said, I'm going to focus on the first triangle first and find big C1. So big C1 is going to be 180 minus the 20.5 I know, minus the 64.783, and that gives me 94.717. Okay. And then to find little c, I'm going to set up my ratio, solve it out, and when I run the math, it's going to run out of space here. It comes out to 34.149. Okay, so I've solved one triangle. There's one triangle. So triangle number 1, there we know that exists. And then here's triangle number 2. Okay, so we're going to find big C2. So I'm going to take 180 minus the 115.21 minus the given angle of 20.5, and that leaves me with an angle of 44.283. So that's big C2. Now to find little c2, again, start with your given values, 20.5. When I run it, I cross multiply and solve it. I find out that this comes out to 23.924. And this is inches. I should put units on there. Okay, so that's how you do it when it's two triangles. Now, the good news is it's not always going to be two triangles. Sometimes it's the really simples. They don't even exist. Sometimes it's just one solution. Let's try one more example of the law of sines, and then we'll do something a little simpler, okay? So looking at number 4 here. Now, I would encourage you to try number 4 on your own. We're going to do this one together in class, all right? Let's flip to the last page of our notes and use a different formula for a different reason. All right, this one is using the area formula for an oblique triangle. Now, if you remember, an oblique triangle means it's got an oblique or an obtuse angle in there. So if I can draw, it looks like this. Something crazy, okay? This works for an oblique triangle, and it works for any two sides and the angle between them, okay? So look, if this is A, this is B, and this is C, we know this is little a, little b, little c, right? So notice our formulas. You can use any version of it to find area. Just depends. It's 1/2 the two sides that you know times the sine of the angle between them. So if I know B and C, then I need to be given angle A for this to work. So let's look at number 5. Sometimes it helps to draw the picture here. You don't have to be perfect about it. It just helps you visualize, what do I have? I know this is 110. I know little a then is 6 and little b is 5. And do I have the included angle between the known sides? I sure do. So I'm in good shape to use my formula. So it says the area would be 1/2 the two known sides, so 5 times 6 times the sine of 110. All right, simply put this in your number, or in your numbers in your calculator. So this reduces to 15 times the sine of 110, and I get 14.095. And if it had units, it would be units squared. All right. Number 6, try it again. Okay, here's A, B, C. I know A is 150. Little b is 8 and little c is 10. So I have what I need. So it's 1/2 times 10 times 8 times the sine of 150. I don't need that. So 10 times 8 is 80, divided by 2 is 40, times the sine of 150. So I get 20 units squared. And that's how we use our area formula here. So it's easy compared to the law of sines. It's less cumbersome. So we'll pick up with law of sines examples in class, and hopefully you're not lost and we're going to be okay. We'll talk to you soon.